Hi, my name is Andreas Abel. I'm Systems Integration Manager, EPT. And today, in this session, I want to talk about the CAN interface setup for the Genesis high-speed power analyzer. The CAN interface is one of the available interfaces for our power analyzers, which have a really low latency, and they can publish up to 2000 results per block per second. I have divided this session into 4 parts. One is the requirements, which is really easy. One is how to set up a recording, and the other one is set up for publishing, because we can do both. And of course, how to remote control a Genesis power analyzer from any CAN bus you have available. The requirements are easy. So first of all, of course, you need a Genesis high-speed mainframe together with a perception software. We call it Power Analyzer. And to make sure your bus is working proper, you should have a 120 ohm termination resistor somehow available, whether it is built in your connector from the cable or wherever. But this is CAN standard. In the first part, I want to focus on the communication between a CAN master, for example, the automation system, and a CAN slave, in this case an inverter. The Genesis high-speed power analyzer is only allowed to be listen to the port, to the CAN port, and not to acknowledge any messages. Because if we acknowledge a message from the inverter to the automation system, or vice versa, it will not be received by the dedicated receiver. How to do that? For each port, you have the chance or the possibility to switch the port into the listen-only mode. This is done in the mainframe settings. CAN for each port, you have to do that separately. If you want to use one port for outputs or for remote control, that is only possible on the CAN port 1. And here you are, in that case, you want to control or output something, you are not allowed to use the listen-only mode. Okay. How to get your message into the power analyzer? First of all, you need to import your CAN DBC file into the perception sensor database. If done so, select it and, for example, via drag and drop, put it to the dedicated receiver and CAN channel. We have 4 ports on the mainframe on 2 connectors available, and each port supports 250 channels. There is no internal termination resistor available. That is, remember, I asked you to have a 120 ohm external termination resistor available. And since perception 860, the sample rate for the CAN could be something between 100 and 2500 Hertz. In earlier versions, it is only 100 Hertz. Okay, that was CAN recording. Press the record button and you are all set. Now, the next section was how to publish. If you have seen my previous video from the EtherCAT setup, you know this publishing sheet already. And you know the button publishing, which you need to press now. If done so, you will end up in this section where you have an overview over all in your system available interfaces. Starting from the GenDAC API and ending at CAN bus. In this case, the listen-only mode needs to be switched off because you see it is not predefined by any signals and it is in light gray, even though here, so listen-only mode is active, you need to switch it off. Click on CAN port setup, switch listen-only mode off, and immediately you can see it is filling up here with some signals and you are able to select the signals you want to set up. In this window, you also are able to set up the baud rate, but I will show you this later. Important thing is, if you are working for CAN or with CAN-FD, you might have spotted already you need to really take care about the timing. And here we have several options to allow you to set up timing, as you will see on a later slide. So change the CAN mode between CAN and CAN-FD. Select the update rate. This is not the same like the recording rate. So the recording rate is the sample rate, and the update rate is the speed, how often we will update the signals on the bus. And this is not directly related to the bus speed. So as well, you can here select the start ID for CAN messages. If you have done that before you start selecting your CAN messages, they will start with this CAN ID automatically. Okay, as you can see here, I started with 100. That was because I selected the 100 as start ID. And it is filled automatically. But if you want to change it, you can override it manually. Same belongs to the byte range, as we always use 4 bytes, lower 4, upper 4 bytes. For our signals, you have to use or you can use the predefined selection, or you can choose something you want to select by yourself. You have some additional information in the same section about the bus state. Again, the update rate, the CAN message ID start index. And if you have done all that, selecting the signals, updating this, you have the chance to, or here the possibility to create your CAN DBC file, which you need for your CAN receiver. Furthermore, you can see how much load we cause, or the power analyzer causes on a bus. This is not the overall load. This is only the additional load created by a power analyzer after you have selected all these signals. Okay, that's quite easy. And that is all you have to do for publishing. And once you have started the preview mode, the system automatically starts updating the bus in the update rate you have selected. Last but not least, we have CAN remote control. It's quite easy to activate that. If you are in CAN port setup and you click here on the control, you open please the CAN tree and go to port 1, select control, then you can activate the enable button for CAN acquisition control. Type in the CAN message ID for the commands you want to send and for the answer you want to receive. Just a hint, we are working according CAN open, but we are not doing it as CAN open. And that is the reason why we cannot publish a so-called ESD file. Okay, if you want to get deeper knowledge about the CAN commands, please press that button here. And then a PDF document will open with all available fieldbus commands. This is a living document because we permanently work on updating those remote control commands, and we update that document as well. So for each perception version since 844, you get remote control commands and the relevant and best fitting document to that. For my example, I want to show you now. I've selected the start preview mode, and we need to know the code 0014. This is a hexadecimal code, which you can see here. Start in preview, byte 0 and 1 are 0014, and all others are not relevant for that command because this is a mainframe command. We have mainframe relevant commands, we have recorder relevant commands, and we have channel relevant commands. And the document is divided into those sections. And regarding the option, if recorder or channel, you need to enter recorder, channel number, command, and you get a return code. How could that look like? For example, with a peak can viewer. This is a free of charge tool. That is why I use it here for demo purposes. In the transmit section, press the right mouse key and edit message or create a new message. And in this section, you can enter the ID 800, 580, or in my case, it was 30 decimal. The command length is 8 byte and enter it here. So the first two, I remember, is 00140. 00140. And once you have done that, you are done. You are now able to start preview in this over CAN connection. Thank you for watching this video. Please feel free to reach out if you have further questions. We are available and happy to support you with that. Thank you very much.